I'm running on Debian. To those who will try to replicate, I haven't tested it on macOS or Ubuntu yet, but I will probably do that in the following days. So there might be some minor problems. It wouldn't compile for now under Windows because there is an issue with the Unix. It uses some Unix specific syscalls, one or two, and I just need to dig through the code and filter them out and use the Windows specific equivalents. So it will take more time to bring it to the Windows, but I think that nobody uses Windows anyway, so it's not a big problem. It's not an urgent problem. And it certainly compiles on mobile platforms, so that's more important. To do the demo, I need to set up the nodes first. And the advised way of setting that up is not to download the code. You can download the code, play it, compile it, but master may have, before the final released version and even after that, master is constantly developing thing. So it's better to compile the released version. And the best way to do that is go outside of the repository. I will do a directory called demo. I already have some data here, so I will just remove them. And I will compile from outside of any repository with the following comments. First of all, I need to get the this storage processor, which called stored, like store daemon. And this store daemon is used by RGB Node as a database backend. So I will start with it, and this thing called which I need to install, cargo install. So the daemon, it's a separate library. And I think I need to use all features, just in case that all the components are installed correctly. Strange why it's not found. Just 1 second.
Crates.io.
Yeah. Yeah, it's here. So daemon. Doing something wrong. Everything correct. Yeah, because it's a beta release, and when there is only a beta release, it frequently it requires you to specify the version you're installing. So you need to put 0.8.0. This will install the latest version, not. So you need to do a specific version. Yeah. So for now, the latest version is 8.0 beta 3, just 2 hours ago released. But in the future, I advise you to check the latest version because they will change, and daemons may not be compatible with if you use different versions for store daemon and RGB daemon. So we have got compilation, which is happening fast. Don't expect to be that fast on your systems because of that. Probably it will take longer. Okay, so the daemon is installed. Now we need to install the RGB node. And the version of it is, the latest version is beta 2, if I'm correct. Oh, no, it's, sorry, I need to use the repo because I haven't released. I was trying to do it before the call, but I didn't have time. So I'm running the cargo install from the repository itself here. But like I will release it in an hour after the call, so you will be able to run the command by using the beta 2 version from here. So we are getting it installed, and here it is. Additionally to that, I need to install another thing, which is RGB20 library. RGB20 library. It provides a command line tool to process, to issue RGB20 assets. As I said, RGB Node does know nothing about tokens in RGB because it hates it. It can't work with the tokens. Since it thinks that they all scam, so RGB Node declines to work with the tokens, and you need to use a dedicated command line tool to issue them and to work with the token-specific functionality. And the version for RGB20 is beta 2. Version. But it sounds really good. RGB Node does not support token protocols. It's so nice.
It's extremely confusing, but very fussy. Fussy, toxic, however you put it.
So you see it compiles RGB core library, then RGB standard library, and on top of that adds its dirty token stuff. Because RGB core and RGB standard doesn't know about anything about fungible or non-fungible tokens as well. So now we have beautiful things, which the first one is the storm stored daemon that does the database storage. So let's run it, see that it works well. Yeah, we have the command called stored. To launch it, you just specify the list of tables, but because the tables are automatically initialized from RGB Node, that you don't need to do it. And we will use a default endpoint and everything by default, but we will use a verbose version so we can read the output. I will check also the other command line arguments just in case not to miss anything. Yeah, that's not required. Let's run it with a multiple version flags. VVV. I think that's enough. So it has started. It opened the socket on this port, which will be connected by the RGB node. And it initialized the internal NoSQL database. We're using SLAT, which is very good known Rust project. So we didn't reinvent the wheel. So the whole daemon is just a RPC wrapper around the SLAT database, and that's all. Very simple. Next thing, we will have to check that we have RGB node. And the RGB node starts with RGB daemon command. Yeah, we have it here. It has more arguments than we need. Let's just use the mainnet version as always, because we wouldn't be doing anything with Bitcoins yet. So we are not risking with anything. And here you can customize the connection to a Storm endpoint, to Electrum, specify the chain that is used. By default, it's Signet, RPC endpoint, connection string to the stored daemon. By default, we will use this one, so it's okay. You can put it into multi-thread mode or multi-process mode, and so on and so forth. So let's start with the default version. Let me double check it that I'm using the correct. Yeah. Nothing to use here. So, and I will again do the verbose version such that we can read out the output. So we are connecting, and we see that it connected because it sent the request to create different tables which are used by the RGB node. So we are there, and it opened an RPC socket to this port. So it should be operational. Now we are opening another tab, and here we will be issuing our assets and do the rest of the dirty work. And for that, we will use two tools. The first one is RGB command line utility working with the RGB node. Very interesting. I haven't installed all features path. Oh, because I need to use RGB 3. Let me install it as well. But it will be installed when you will be installing it from outside the repository. It will be installed with the... No, you will need a dedicated command, which will be cargo install RGB CLI. Because you can install command line tool without the node itself. And that's why we have a separate library for it. So you will use this command once it will be released. So it should be installed now. RGB install. It's there. And so this tool connects to the RGB node. Again, it can use custom chain, and these are main commands that can be used with the node itself. And we will go through all of them one by one. For now, I do one thing. I will terminate RGBD and use it with a mainnet. Okay. So let's check what we have there. RGB CLI contracts command give us the list of the known contracts. Yeah, but because we need to now specify the chain, we default to the signet. We need to add this parameter. So we have two contracts already, which I was playing with. So I'm just showing how it works. And we see that RGB node got this command, and it processed this command from the client. And each client has a unique identifier that allows the node to work with an arbitrary number of clients. Okay, so we can work with RGB node. Now let's see what we can do with RGB 20 assets. Under RGB 20, do we have it? Yes, we have this command. And this command doesn't work with RGB node. It works locally, and it helps us to prepare the information for RGB node, which is an asset specific. So let's try to issue some of the assets. Then the first thing that can do, we will use network coin, and we will issue. Let's see how we can do it. To issue the asset, we need to specify ticker, name, and allocate this asset to certain transaction out points. We also have an opportunity to add different inflation, stuff, precision, customization, renomination, which we don't need now. It will be required for very advanced asset issuance, so I wouldn't spend time on that. So the ticker, what would be the ticker? Let's make it RGB. And the name will be scam coin. And the allocation, the interesting thing, how you specify the allocation is exactly this way. So you provide the explicit single usil definition here, because you don't need to hide from yourself which transaction output you use. And you put the amount in front of that. So this amount will be amount of the primary issued asset, which will be put on your transaction output. So this transaction output should be owned by your wallet. But because we are not using wallet right now, we will just take the arbitrary transaction from Bitcoin, like this one, and we will use the first output. So we will issue 100 of RGB scam coins to this transaction first output. And that's all. And we've got the issuance. So I didn't talk to RGB node, nothing happened here. What it did is created a new contract with this contract ID. All the contract ID start with RGB1 string. And it basically a hash of Genesis block. This is the explicit form of Genesis block. If you'd like to parse it from your wallet or for any other reason, the Genesis commits to a schema. This is RGB20 schema. It is done on mainnet. It contains metadata about asset name, the precision, which is default timestamp, and the amount of asset that has been issued. We have this owned rights for a fungible type, which is basically an old name for this value thing, which uses Pedersen commitments to create the commitment. And this is the explicit value. We didn't conceal it. We have the seal definition using tap-red first algorithm on this transaction ID with a blending to the seal. And we don't use the blending because it's primary issue here. The same contract in JSON, just YAML, and this is JSON. So those who like Ethereum style, you have this contract. And the contract source encoded as a backstring. This contract source is actually that contract consignment and the information that the contract issuer will distribute to all the contract, to all the future asset owners, or publish into Bitcoin Lightning network. And if the issuer will do the second issuer, this contract source will get longer because all the secondary issuers, renominations, and so on will be added to it. So this is actually the consignment, just small one. We need to add this contract, newly issued contract, into RGB Node. And that can be done quite simply by doing RGB Node, register. RGB register. And what all we need to supply is to provide this contract source, nothing else. It got validated by through this small period of time. For that, it started the new container daemon instance, then it validated and imported the contract. We can see that happening here. And if we will go through the story, we have that container D has been started. Runtime started successfully, then it connected to the main RGB daemon. Then it get this task, registering consignment, this one. It starts reading objects from database, processing contract, validating consignment here, and then storing it to the database. So the object is not found because it was absent in the database before. And the validity was returned that the contract is valid. So that's the story, how we add it, and how we can see that it's indeed there is by using, again, this contracts command, and we see this new contract. We will, I got clear, but basically that's the contract that we just imported. I don't remember which one of them actually. So let's probably this one. We can now read the contract. For that, we need to provide the ID. And we will get back this string with the contract definition if we need it. But what is more interesting is to read the contract state. And for that, we have the command called state. And we got, the ID is correct. We got this contract metadata, RGB coin, our scam coin, and we have hundreds of assets allocated to this transaction output. And this is a blending factor that is used for the Pedersen commitment. You see that here, when we ask the contract for the state, when we ask the node for the state, it doesn't know what it is. So it doesn't say that it's an amount. It says that it's a value with a Pedersen commitment. And here it will list other types of the state, like data, attachments, and rights. So this node works with any type of the contract. Now we can do a transfer. We can start doing a transfer because we wouldn't be able to complete it without the wallet doing the signature and actually spending the Bitcoin transaction output. So to do the transfer, we need to construct a new state transition which takes these assets and sends that to another new beneficiary. And because this state transition, the state transition composition is always schema specific, we can't use RGB Node to do the state transition. We're using a schema specific library or tool to construct the state transition, the last one, which will be added to on top of the consignment. So we are using RGB20 command for that. And the name of the command is, we need to do two commands. The first one, we need to generate a blended UTXO value for the beneficiary. So that will be command performed by the beneficiary. And then we need to do the transfer command. So let's generate the blend value first. And for that, I will take another random transaction, the next one, and we'll use the second output. So blend this one and use the second output, third actual output. That's all. And I have this confidential single-use seal definition starting with the TXO-B1 string, using this blending factor, which I have to save for myself and provide to my RGB node, such that the node can recognize this string and accept the consignment as of its own. So that was operation done by the beneficiary. Now I'm back to the sender mode, and I'm using the next command, RGB20 transfer. And I don't remember the parameters, so I'll do the help. So, and I need to specify which UTXO I will be spending. So from which UTXO I will be sending our assets. Then I need to provide a file of the consignment, which I have to first prepare with RGB Node. So I was wrong that the RGB20 used first. RGB Node creates consignment, and on top of that, RGB20 constructs the last state transition and the list of beneficiaries. Finally, I provide the file where to store the state transition to. So let's start with the RGB CLI then back, and I will need a command called compose. Build state transfer consignment draft. So compose, help. I provide contract ID, out points, which are actually points which I am spending to send the asset to, and output file to sign the consignment prototype to. So let me check the contract ID here and do that story. So compose contract ID, then out point, which is basically that out point holding the asset. And then I have just a single out point I'm spending. And then output file, which will be local file. I will call it transfer. Let's call it scam. RGB C. I'm using the RGB C extension for saving consignments. Okay, so RGB talked to the contract. It used a new container daemon to compose the consignment, and it saved consignment to this scam RGBC file, which I can see by the ls program. So here it is. I will move it to the demo wallet. If I will see here, I will see that there is a lot of processing happening on that, and container daemon preparing new consignment. We can look into this consignment, how it looks like. So we can use a hex view. So you see the information about the schema, which contains that type system I was showing in the presentation, out point, transaction ID, and so on. We have that we are connecting to Bitcoin main network, scam coin, RGB, and this all data of the original issuance. This consignment doesn't contain transfer itself. It's a base for putting transfer on top. So with that, I'm going back to the RGB20 transfer. And for that, we need to specify, where is that transfer consignment, beneficiaries, output, and UTXO. So UTXO, the input UTXO is the same I'm just used. It's not part of the consignment. That's why I need to provide it once more, this one. Then I need to specify a consignment file, if I'm wrong. Yep, consignment beneficiaries output. Consignment is the scam consignment file. Beneficiaries is the transaction that I just blended, transaction output that I just blended above. Here it is. So I will be using this one. And this beneficiary information probably should contain the amount of the asset. So I will send all of it. And finally, I need to say which file to save the state transition to. So it will be RGBT file. Done. So this is the generated transition. It's just print out of the transition. And here it does the transfer to the new blended seal. And I can see this new transition file generated. It's just 130 bytes containing the bulletproof and Pedersen commitment here in hex. So there is nothing interesting to read here. And now we are going back to the RGB node to put together the consignment and the transfer of the asset and create this state transfer file. RGB3 help, and this time we will need a command called transfer. But the problem for that for composing the transfer, we need a PSBT prepared by the wallet. Why? Because preparing the transfer, the node analyzes, are there any other contracts, RGB contracts known to it, which use the same outputs we are spending in this transfer? And if they are, it prepares the additional disclosure for itself to use it later, and blank state transition. So if we will do the transfer command with the help, we will see this detailed description of what this transfer does. Add transfer information to PSBT, generate blank state transitions for all other contracts affected by the given PSBT, and it's to the PSBT information about the state transition, and also disclosure, and also all of that. So I need a contract ID, transition, and PSBT. And that part we will continue on the next demo when we will have the wallet, and we will continue from this point on, sending the consignment through the Lightning Network and accepting it on the other side. So probably that's all for the demo today. And if anybody have any power to ask the questions, I will be happy to answer.
Okay, I have a couple of questions.
Yeah.
So, first of all, regarding the PSBT file, what does it expect, as a valid PSBT? Does it need to have already like a taproot output? Then it will be
Yes.
okay.
And or op return if you are using op return. So it
okay.
has to be.
Yeah. Okay. No. Go on. Sorry. No. Yeah. I want to. In case of op return, do I have to already prepare an empty op return, or it will just create an op return by itself?
No. You as a wallet have to prepare PSBT containing the final list of inputs and outputs of the real transaction you're planning to do. So the only thing that RGB will modify in the Bitcoin transaction itself is adding this tap return commitment. It's the only thing.
Okay, so but in case of the op return, so it will basically add the commitment inside the op return. So I prepare a transaction with an empty op return, or
no, with a normal, with your op return, like sorry, if you're using op return, not tap ret, then you don't need to add op return. It will add op return.
Okay, we'll add. Okay, so I just create a random transaction. Will I just send myself change and it will add op return? Okay.
Yeah. Sorry, I'm constantly doing the tap return version, and that's why I'm.
So with the tap return, basically just create like a taproot output that sends money to whoever I want to send, probably myself, and then it will.
You can say that type of that, but give me 1 second, and I will show you the actual information about PSBT. Just 1 second, I will switch the screen I'm using for sharing. Start screen sharing. So you see my your screen with the presentation?
Yes.
Okay, so you see here the amount of fields, of PSBD fields used by RGB overall. So it's a little bit more complex than just adding one thing. And we have more than a single command to work with PSBD. So actually there are two commands. The first one, which we will going to do, is the transfer and then a finalize. And there are two different roles called RGB updater and RGB finalizer. And the difference between them is that when you do a transaction with the multiple signers, you first do the first one, then you pass PSBD between the signers, they add their information, and then you finalize the PSBD as the last party who will be completing this thing. Because other signers may add other outputs, other inputs, and these other inputs may have other RGB assets, and they need to properly bundle their state transition of the same RGB contract and add other RGB contracts. So it's the actual workflow is extremely complex inside the RGB node itself because of all these factors. But from the wallet integrator, it calls the RGB node 3 times. The first time to do the consignment, and it doesn't need PSBD. The second time, when it drafted the PSBD that contains all inputs, which will be part of the Bitcoin transaction, such that RGB node is able to compose together the new state transition with existing consignment PSBD and do all the processing for the rest of the inputs. And it will return the processed PSBD, which you will share to other cosigners, which will do the same with the RGB nodes. And the final consigner will call the finalize method, which will actually take all the information from all assets and contracts which are part of this PSBD and pack them into a single tapret, add the tapret tweak to the output, and finalize the transaction.
Okay.
So it's that complex.
I see. Okay, so then, like, my second question was regarding then the consignment file.
Sorry. In this link, I tried to describe this process. I'm not sure that it's really very readable, but I will share it to the chat.
Okay.
Yeah.
Amazing.
So, sorry, go on with the question.
Okay, yeah. So with my second question was regarding the consignment file that is produced. Like, so you said that, yeah, then it will be like through Bifrost, you will be able to share it with the receiver through the Lightning Network.
Yes.
But is it also possible to just export the file?
Yes.
And, okay.
Yes, there is basically when you send it, I will show you already in the comment. So it's all there. It's just without the wallet, I'm not able to demonstrate it or properly debug, but the implementation part is done. So if you use RGB CLI, you will see this finalize command.
Okay.
And we will do this finalize help. You will see that, again, it describes what it does. So you take PSBD file, you take consignment in, it produces consignment out, which can be stored into the output file. And also you can provide it with an argument send with a Bifrost server address to send state transfer to. So it always saves the file, export files, but also can send through the Bifrost network if you'd like to.
Okay, very nice. And so, and then, like, to validate it,
you validate it at the moment when you import it. So if you have this, probably I haven't added to the command line tool yet because I haven't got to that part yet, but there will be a command called consume here, like the register. And it will do the same as I showed you with the registering contract, because from the RGB node perspective, the contract consignment and state transfer consignment are processed in exactly the same way and validated exactly in the same way. So you can use basically a register operation and it will do the same. But I will do a separate command just to make it more clear.
But with the registering should also work.
Yeah, it should also work with the
Okay,
register.
so if I do register and then I provide this consignment file, you should be able to like
Yes,
import it and
it will
validate.
validate it and import only if it's valid. If it's not valid, it will return you the status report with all the
Okay.
issues discovered.
Okay, good. And so to validate it, it just validate that the consignment is correct, or also validate that the transaction is being confirmed on the blockchain?
It validates the consignment to be correct, plus that all transactions are mined. But there is a special argument which you can pass that if the last transaction is not mined, you can still force to accept it.
Okay, so basically he already checks the blockchain by connecting to
Yes.
a blockchain indexer.
Yeah, that's why I showed you in the RGB node when we started it. There are parameters with the Electrum server.
Okay.
So you can customize them. You need to run it with just a second. I will interrupt it. I will run it with a more flex, and I will see the whole story. Okay, I don't see it here, but if you try help, we will see that there is Electrum server connectivity. This one. So
Okay, so it's from here that I can choose which Electrum server to use.
Yeah.
Okay. Nice. Got it. Okay, so basically one needs to set up the RGB node with an Electrum server, and then to have like a wallet able to create a PSBT and then send transactions.
Yeah.
And make
But
all of
you
this.
have to equip that PSBT with a proper flag. So once again, we'll switch my screen sharing here. So this PSBT need to contain this tapret committable part.
And how do you flag it?
And no, you don't need it. You just add a tapret committable proprietary flag with this prefix to the outputs, which may contain the. You are using not tapret, so you are using opret. You don't need that.
Okay, in case of opret, I don't need anything, and in case of tapret, I need to add.
In case of opret, you don't need anything.
And with tapret, I need to add this flag in the PSBT.
Yes, to those outputs which may contain tapret commitment.
So let's say I'm using like Bitcoin Core, where I create the PSBT with Bitcoin Core, and then with another software, I add the flag to the PSBT.
Yeah, you can use the descriptor wallet for that. It allows to attach flags to the PSBT.
Okay. That's it on my side. Thank you for the answer.
Thank you for listening for all that. Any other questions or general comments?
Yes, if I can.
Yeah.
Thank you for your work and your time. I'm sorry if I'm like going into another direction. I understand this is a technical call. I was just wondering, will you be in the future revealing or just commenting, giving some information about the economic impact of RGB? In a sense that I mean, for example, Ethereum has recently published intentions to make soul-bound tokens, right? Like a new standard. Will technologies like RGB or other Bitcoin layer 2-3 protocols enable a faster development of such protocols, which would have impact in terms of economy, governance, and other application areas?
Sorry, once again, which tokens Ethereum has promised to do?
Soul-bound tokens that are non-transferable.
Okay.
Which is seems like a very simple, obvious thing. They should have been around for a while, but it wasn't. So I'm wondering if technologies like RGB would enable a faster evolution of that kind of things.
Well, I don't think that RGB will allow something that wasn't possible before with Ethereum. Probably everything that you can do with RGB, you were able to do it with Ethereum. The main difference is that you can do that with Ethereum as a proof of concept and wouldn't be able to scale. While with RGB, it would be scalable and also very confidential based, privacy, with a strong privacy feature. So I don't think that RGB will unlock something not possible with Ethereum before, but it will bring it to the real possibility of production use. The second thing that RGB can do is, together with the other components of the Lightning Network, it can do something that was not possible with RGB, with Ethereum, like forms of the access over the Lightning Network, or even more advanced smart contracts like computing and so on, decentralized computing. So that's what we will be working on as also as an association in the future.
Thank you very much. That makes sense. If I can, voice some desire.
Sure.
Yeah, it would be very nice if you could elaborate more on these kind of things, like related to application areas, so that the topic is more interesting for economists, managers, people which are less technical, but are more interested on the, you get it, right? Like the economic impact of those things, which is like the end result of the technology. Like again, like Ethereum and other ecosystems, without having any benefit, just making a lot of papers and objectively contributing a lot to the area as well. So if you could participate.
Yeah, it's just two different scopes. I just last week was giving a presentation exactly about the business part of the RGB impact in the new shuttle, and that was more business audience. But developers there said, why you don't saying about technical part? So now I'm doing the dev call with the technical part, and people saying, where is the business part? It will be like 5 hours if I will do both of them.
Well, I wasn't able to participate to that call, but
sorry?
I'm a business guy, and I wasn't able to participate to that. I think you're.
I think we will share. There was a video recording from that presentation, so probably that will be more informative for your questions. But overall, we're trying not to create too much hype because the technology is very young and early, and you don't have good developer tools right now, so it's just getting released. And if there will be a big hype from the business, there will be no developer force to fulfill that demand. So we would like to take it slowly, probably. Yes, because we are not doing ICO, we don't need to fight a lot of investors.
Thank you, Maxim. That makes sense.
Yeah.
At any point, if you are able to do that, or you have a research team which are working on it and I can contribute, would love to just participate to that kind of conversations. In the meantime, thank you for your time.
Thank you very much. Thank you. Okay, I think we had it all.
From my side, I must admit, taking into account what you explained, what we just saw with regards of the processes that have been happening, RGB is freaking fast. I mean, it was amazingly fast.
It's just a very fast computer.
Yeah,
but yes, the architecture is designed to be fast, so that's the whole idea. It's all written in Rust, and all the even though you have a lot of processors and daemons and threads, they are really very optimized, asynchronous, non-blocking, and all that stuff. So yes, we put a lot into architecturing this thing. Again, the goal to be able to scale it from mobile phone to the enterprise cloud.
Nice saving to hide that you are using an NSA computer. Very nice saving.
That I'm using, sorry, what?
No, sorry, just a stupid joke.
No, I like it, but I didn't get it. So
you try to hide the fact that you are using an NSA advanced computer like Satoshi did. Very good attempt.
Yeah, absolutely.
It is impressive, though, considering that the majority of the web is like on these massive load balanced data centers just to scale. They don't really bother to make it like optimized enough that they could run the whole stack on their own computers. So it's always impressive when you can see a large, like a good amount of functionality run on a single computer these days. As unfortunate as that observation may be.
Yeah, you're right, actually. And that's why we did this thing, which is related to the microservice of architecture and communications as a separate GitHub organization, this Internet to Big work group, which is not related even to Bitcoin specifically at all, and such that people from outside of Bitcoin projects can use that for their architecture. We have another team using it already independently, so they grabbed it and they're very happy. And we also use it at our own company when we were doing Exchange and other projects with RGB for running Exchange, running custody, and running many different things. So hopefully people will grab this architecture and start using it in a more broad context.
Yeah, the 0MQ based microservice messaging architecture is it pairs particularly well with Rust's versatility in that you can embed this library into another program. You can compile that program into WebAssembly. You can use in-proc communication to embed, communicate through all the embedded parts. And so it is a really versatile protocol, and it also could, conversely, beyond like say Raspberry Pi or running all on an ARC64 on a phone. You could also, compile it to be used in a server or in a desktop app. You could use shared memory. It's just incredible, all the different applications and composability that you can get from a flexible architecture in addition to such a flexible language.
Yeah, that's true. Absolutely. Okay, I propose to finish the call today.
I think it's officially the longest call we've ever had, 3 hours, 22 minutes.
Oh, shit.
Yeah.
Thank you, everyone, for staying through all this time with us.
Thank you, guys.
It was a pleasure. Thank you.